Okay, I didn't hear a beep. I don't know if it's recording. Now, I know in the last video, I thought that I was going to be up here in the corner, up in this corner, but I wasn't. I don't know if I am this time. I guess we'll find out. I was a second ago before I clicked record, so we'll find out. Now, in class today, which again is Wednesday for the B1 people, it'll be Thursday for the B2 people. Pardon me. This is what you were supposed to have done for today. And the very first question here, which variable is manipulative and which one is responsive? Now, I'm going to remind you that as you read the descriptions here, to determine which one is manipulative and which one is responsive. I had a lapse of brain activity there. You have to read the description as to what it's telling you the experimenter is doing. So again, Troy, this physics student, wants to see how the height of a ramp will affect the rolling distance of a cart. How the height of the ramp will affect the rolling distance. So already it should be kind of a clue that there's a cause and effect going on here. And it's the height that is probably going to have an effect on the rolling distance of the cart. Now, it goes on to say he uses a ramp and a stack of books to change the ramp height several different times. To change, so he is using the ramp and a stack of books to change the ramp height several different times. The word change or alter. So if we see the word, if we see the word change or alter, what are those words telling us? Maybe I should turn it this way. What are those words telling us? To alter or to change? We're talking about manipulating. So this means to manipulate. So if you are changing it or altering it or whatever other word that means change, that is manipulate. So Troy is manipulating the ramp height. He's changing the ramp height. So that has to be the manipulative. The ramp height is the manipulative. That means that the responsive has to be the roll distance. The rolling distance is what is going to respond to or depend on how high the ramp is set. I hope that makes sense. Now, something I wrote down on the board here in class, which I think I did it yesterday, which would have been, I don't think I included that in the last video, but here's something to think about. X and Y, in terms of the axes, X and Y, which letter comes first in the alphabet? I hope you're thinking X, Y, Z. So X comes first in the alphabet, then Y. Now in terms of M and R, for manipulative and responsive, for the M and the R, which one comes first, the M or the R in the alphabet? I hope you're thinking M. So M comes first in the alphabet, R comes second in the alphabet. Now, hopefully, again, if you can't remember this any other way, maybe you'll remember that the two letters of these pairs that come first in the alphabet go together. That means manipulative on the X. The two letters in those two pairs that come second in the alphabet, those, again, the responsive is on the Y. So maybe that'll help, maybe it won't, I don't know. But you had to establish that before you did anything else with the graph. Okay, so this is the actual graph. So hopefully this is what yours looks like. Now my ramp height, I ended up going by 5s. Originally I had gone by like 4s and then realized that the data, because I hadn't even been paying attention to the data, that the data was going by 5s and 10s. And then I had gone by 4s across the bottom. And then the class was like laughing at me because that's not very smart to go by to pick an interval that you're literally not going to have any, well, except for 40. 40 would be the only one that would show up. No, 20 would as well. on an actual line. So not smart. So then I changed it from 4s to 5s. So I'm going by 5s here across the bottom. Again, you only see 10s, but it's 5, 10, 15, 20, so on and so on and so forth. For my roll distance, I got to get up to 253. So I couldn't go by 10s because I've only got 17 boxes, and that would only get me up to 170. So 20s, I didn't really want to go by 20s and shrink my data a bunch. So I went by 15s, which, I mean, it's not my favorite, but it worked. Plotted the points, drew the best fit, and here we are. So next question. The actual question after you get the graph done is there a relationship? Well, what do you think? That's the same as asking, is there a cause and effect? Is there a cause and effect happening here? In other words, is the changing of the ramp height, is it affecting the rolling distance? I think it's pretty clear that it is. I hope it's pretty clear. That's the wrong one. So I hope it's pretty clear that as the ramp height has been changing, so has the rolling distance. Now, what would the data look like if that wasn't true? If the rolling distance was unaffected by the ramp height, then what might we see? Think about it. If the rolling distance was unaffected by the ramp height, so the ramp height continued to get bigger and bigger and bigger, and what happened to the rolling distance? It did not change. So what does that look like in a graph form? Well, let's just say, like instead of this data right here, it would be like 50, 50, 50, 50, 50, 50, 50. That is what data would look like if there was no relationship. Now, what does that look like on this graph? What would 50, 50, 50, 50, 50 look like on this graph? Well, where is 50 on the first data point? Well, it'd be kind of like, that. And another one about where that is. And then another one here. And then another one here. And then the next one here. And then the next one here. And then the next one here. Do you see what kind of line that's going to produce? That's like this. That line is going to be horizontal. It's going to produce a horizontal line on the graph. And that means no relationship. That means you change the one variable over and over and over again, but then nothing ever happened to the responsive. The responsive didn't respond. And if it doesn't respond, then we say there's no relationship. I should have asked the question. Let me undo this real quick. I should have asked the question. Oh, and I got all that stuff. I guess I can just... On this slide, on this question, I should have asked, how do you... What the... Is that the... What the... Didn't I... I thought I already wrote something up there. Cause and effect. Oh, that was on the wrong slide. That was on this slide. Oh, my Lord, have mercy. Cut that. Cut that out. No wonder. Paste it. What the? No. Paste. All right. So, cause and effect. Is there a cause and effect? Yes. Now, that means, yes, there is a relationship. How can you explain? Like, how do you know that there is? Well, there's an effect, which means the line is not horizontal. It actually has a slope to it. There's a slope to the graph. And because there's a slope to the graph, so is there a relationship? Yes. The ramp height affects, oh my gosh, the roll. And again, by looking at the graph, how do you know? There is a slope. to the graph. And I don't care if it's curved or straight. I don't care what the shape of the line is. As long as it's not horizontal, as long as it has a slope somehow, that means that the roll is being affected by the height of the ramp. Now, is the data proportional, and how do you know? Well, what we said the other day about proportional, remember, a proportion is a ratio. And so, is there a ratio to this data? Yeah, I would say there is going to be a ratio here because it has a what? A slope. It is. So is the data proportional? Yes, because, and again, how do you know? It's linear. It is a straight line with a constant slope. So it is a straight line with a constant slope. That means it's directly proportional. That means the roll of the cart, the roll distance of the cart is directly proportional to the ramp height. All right. What ramp height would be required to get a roll of 175 centimeters? So we're looking for ramp height. We're given a roll of 175 centimeters. Well, I hope you went to the graph, and I hope you looked at your graph and you started where? Now, it says show your work on the question, and that means draw a dashed line on, or dashed lines on the graph so that I know you know what you're looking at and how this works. So you're going to start where? I hope you're thinking that you're going to start at the 175. Now, that's 150, and that's 165 because I went by 15s, and that's 180. And so then I have to split my boxes into thirds. So that's 165. That would be about 170. That'd be about 175. So I start at 175, and I head over to my best fit line. And then, kaboom. Oh, whoa, this thing's going nuts. I head over to the best fit line. There it is. I stop at the best fit line. And where it intersects, I take it down like this. And I see, oh, that's right there. Well, how much is that? Well, that looks like a 35 centimeter. It's right between 30 and 40. So that looks like a 35 centimeter ramp height. Now, what if you didn't get that? What if you got 30? What if you got 32? What if you got 37? Like, I don't know that I care as long as it is correct on your graph. So for me, it was 35 centimeters. How did I show my work? I sketched on the graph. You have to show your work by sketching on the graph. That's the only way you can show me. There's no calculation to do. There's no math to do. You simply show me with dashed lines on the graph where you were looking to find the answer. Now, next one. What roll would you get if you had a ramp set at 25 centimeters? How much roll would you get if the ramp was set at 25 centimeters? So we go back to the graph. So where's 25 centimeters of ramp height? Well, right here. So what do? I look up to the best fit. And once I hit it, I take a left. And I get right there. Now, if this is 120 and this is 135, then that's probably 125. That's probably 130. And again, that's 135 there. So it's going up. So a third, that's 5 each. So it looks like I'm in about the 125 range here. I'm about 125 centimeters there, in my opinion. Now, maybe for your graph, maybe you ended up right here at the 120, or maybe even closer to 135. Maybe you're at about 130. I don't know. Because remember, your data points are guesses, your best fit's a guess, and now you have to guess again to get this answer. So as long as it's correct on what your graph is showing me, then you're good. But notice on these answers that I'm putting down. So this answer, again, I would say that 125 centimeters would be my answer there. And again, what's my work? I showed it on my graph with my dashed lines. Notice though, Both of these numbers that I wrote on these questions for answers have what attached to them? A unit of measure. If you just put 35 and 125, you're going to lose points because you have to tell me what those numbers mean. 35 what? 125 what? All right. Lastly, finally, find the slope of the line and show your work below, including the units on the slope. Okay. Again, it says show work below. Now you're going to have to write something in this blank. Now you can do it on the graph, but I need to see what you did in the blank here for this question. And again, it says include units on slope, which some people aren't doing at all. So shame on you. Now, in terms of finding the slope on this line, well, you kind of found some places already that you already had to estimate. So, I mean, if you know how to use these 2 points right here that you already found, then just use those to find your slope. You can do that. I'm not going to explain how. But if you can look at those and you're like, okay, yeah, I know how this works. I already know what the answer is going to be. Why is this thing not cooperating? Then by all means, use that information. I'm going to look at my line here and I'm going to say, oh, that's a perfect one right there. That is exactly on a grid intersection. And, ooh, this one is 2. Now this one here, yes, there was a data point close, but I want you to look. The data point is actually above the intersection. See, the data point is above where it hits that intersection. I should change colors. Oh, that's the same color as my dang line. How about green? So I'm going to drop that down like this. And again, if you don't have perfect grid intersections, then you're going to have to estimate in between the gap. Now, because I went by 15s, I got to count by 15s. So my rise is 15, 30, 45, 60, 75, 90, 105, 120, almost lost it, 135, 150. That is my rise, 150 centimeters. Now my run, since I went by 5s here, is again 5, 10, that's a 5 there. Oh my gosh, 5, 10, 15, 20, 25, 30. Boom. I went 30 centimeters for my run. So there's my rise, there's my run, 150 and 130. So then I go down here to my question. Right here. Okay, find a slope. Okay, so here's my slope. My slope, again, rise over the run is, I had 150 centimeters for my rise over 30 centimeters for my run. Now, I hope you can see that that's about 5. I hope you're getting something that's close to 5. Now notice what the units of measure are. It's centimeters over centimeters. I don't even know what that means. What does that even mean? Well, it's weird when both of our variables are measured by the same unit of measure. But let me see if I can explain. If we try to write this out, this sentence, this slope out in a sentence form, then it will make some sense. I hope. So follow along. 5 centimeters is the rise. Which variable is going up by 5 centimeters then? I hope you're looking at the graph and you're seeing that that is the roll distance. So here's what this is saying. We have a 5 centimeter to 1 centimeter ratio, right? Remember, our slope is a ratio. That's the ratio. It's a 5 to 1. 5 centimeters to 1 centimeter ratio. And so here's how I would write this out. There are 5 centimeters of what? Roll distance. 5 centimeters of roll distance for every, or per, for every 1 centimeter of what? Ramp height. I hope that makes sense. That slope is telling us how much more roll distance we get for every centimeter we add of additional ramp height. So there's a 5-to-1 ratio of roll distance to ramp height. So that's why the centimeters and centimeters, you kind of need to put the names of the variables attached to your top and your bottom of your ratio to make it make sense. So I hope that makes sense, because that's what you're going to need to do for the quiz. All right. So that's it for this one. I just posted another one on Classroom, which you'll already know. Well, if you were here, you'll know about it because I'd already told you. But I posted another one that's very similar to. Oh, and again, don't worry about 8 and 9. You don't need to do 8 and 9 because we're not doing that. So for the next one, same situation, right? Different scenario, different set of data. So it's going to be a different experiment going on. It's going to be a different set of data, but you're still going to have to be able to identify which one is manipulative, which one's being manipulated or altered or changed by the experimenter, and then which one is responding to that change. So I hope that last little bit of practice will help you out. There's a due date on there as well. You're going to have that finished before you come in for the next class you have with me. And then the quiz will be after we talk about all that sheet's answers and any questions you might have on how to be able to answer those questions. We'll clear all of that up before you take the quiz on the next class that we have. So for the B1 folks, that's going to be Friday. For the B2 folks, that's going to be Monday quiz. And then we'll finally be done with data analysis and we can start getting into some actual science stuff ourselves. So I hope that makes sense. I think that's it. Have a good one. We'll see you when we see you. Take care.